Sorry, the recording crashed there. So we have audio in. It's all going wrong. We have audio in going into our gain and our easy DAC. We want to introduce a new patcher. We're going to save this as new patcher. We want to save this as, so we're going to go up to our blog freezer. I'm going to do tutorial, and then I'm just going to call this one mmfreeze save, and then I'm also going to save this patch file, save as, in that same folder. So now I can reference my freeze object. Double click it. It has absolutely nothing in it, but we can get started. So we know the first thing we want to do is bring in our FFT in. We need to declare, so I'm going to do FFT in 1, and that just says we want to create the first inlet to be the FFT in. We need to take our data and do card-to-pole. So we're taking our Cartesian coordinates and turning them into polar coordinates. Again, if you don't know much about this, I would have a look at Cycling 74 have an amazing tutorial up. It's got about 5 parts, and it goes through really basic all the way to pretty advanced stuff in about an hour, hour and a half of looking at the FFT object. So please do go and check that out. Right, okay, so I've got my card-to-pole. We don't really need to do anything to that because we don't actually want to alter the data in any way. We just want to capture a very small section of it. But we do need to wrap our data slightly. So I'm going to frame delta and bring up the reference so we can have a look at what we're actually doing. So I've got my frame delta, and this just computes the deviation between successive frames. So this, instead of having a spectral chart that say you could scrub between two spectrums or two sections and it would sound like there's no audio because it's cut off, this will help fill that in. And then we want to wrap our phase, so phase wrap, and this will just bring the information coming out of frame delta and turn it into something that makes sense. So if we do number, that should make sense. I don't know if this will let me properly take a snapshot. Probably not. No, that's not going to work. Oh well. I can guarantee you what's coming out of frame delta will be in a range of about 0 all the way up to 100 or so, and what's coming out of the phase wrap will be between -3 and 3 sort of range. It just keeps things neater so that when we eventually wrap it back together, it all makes sense then. Because we do need to, now that we've gone card to pole, we need to go pole to card before we can output the information again that the max MSP timeline based stuff will understand. So in here, we are going to put this into a jit.catch. We're going to do 2 channels. because we have real and obviously imaginary. And then we're going to put this into mode 2. And this is the sort of thing that I didn't know about. So if you have a look at the mode message, this is where the tutorial from Jean-Francois came in handy. So in mode 2, a frame size is the most recent. A frame size of the most recent data is outputted. Essentially what that's meaning is it's capturing a frame size and then outputting only that data. It's not outputting anything else. And that's important because we only want to capture one frame worth of data to make that freeze sound where it's constantly holding that one value. Into this we are going to plug in our original input value, so we've got our amplitude, and then we're going to have our phase of each sound coming into the catch. And then this catch is going to go into a matrix. And then I'm going to give the matrix an arbitrary name here because it's something we're actually going to need to set later to be able to do the stacking part. So I'm going to give it a random name. I'm then going to give it 2 planes, tell it to expect float numbers, and then I'm going to give it an arbitrary number of dimensions. So I'm going to do 2048 here, but this number is actually going to be set by whatever sample we try and record inside here. So I'll connect up my matrix. I'm then going to make an in 1. So this means the first non-FFT input is this inlet. We're going to pass that into the sorry about that. Yeah, so we need to do 2 things in here. First is we need to send a bang from the outside world into the jit.catch to tell it to capture that one sample worth of data. We then need to tell jit.catch and the matrix how long that sample is meant to be. So we're going to use the FFT info object. Now this has basically just a blank signal on top. But while your audio processing, while the DSP is active, inside a PFFT object, this will constantly output the size of what is coming in here. We are going to use the spectral frame size information. Oh, no idea what that is. To set the size of our objects. So I'm going to prepend frame size. And plug that into the catch. And if we look at the catch, you can see frame size is the output matrix width. So we're preparing catch to record the correct amount of data. And then, so we don't waste audio or have blank space, I think it's just dim we want to prepend here. Dim, yeah, dimensions of the matrix. Oh, that's deep. We plug that into dim, we plug that into the matrix. So now every time that a sample is loaded in the FFT object, catch will be set to the right size, and so will the output matrix of it. And all that means is that it's only capturing that really, really specific small frame rather than the whole audio spectrum. And that's that done. Next thing we need to do is actually process that data. And these are 2 completely separated parts. We're going to jit.peak into our matrix name. So I'm going to give it the name. And then, because we know our matrix has 2 planes over a undefined at the moment amount of dimensions, we're going to set the dimension input count on this so that we sample the correct thing. So on the first one, I'm going to do 1, 0, and on the second, I'm going to do 1, 1. And if you've ever done any work with, the name of it escapes me. I can't think of the name of the object at the moment, but it allows you to, you use it for mixing audio signals without degradation, and it uses sort of this method. So we know our original matrix has 2 planes, so we set up our peaks to go and look at the first plane and then go and look at the second plane, and we use these to build up the phase and amplitude, and then the real and imaginary numbers that make up our sound. So it just makes sure that the sound that comes in is the same sound that goes out, because you need to represent both of those properly. If the object comes to me later on, I will pause and jump back to this part. We connect our peak to the current bin index that the FFT is operating in. And this just makes sure that again, the sound is rebuilt the same way that it should be. We make sure that the phase is correctly accumulated over time. And then we just pull to car. And then with that, if we save it and close it, excuse me. So we repaste that, it should have an outlet. Excuse me. So now hopefully, all things going smoothly, we pass a bang into the same inlet. Oh. Bang into the same inlet, and it should, he says should, have an output. So it wouldn't really make sense, because of the input is sort of talking. It's more for capturing tonal values of your voice as you go along. So if we do something, let me just bring over another object here. So let me put in this one, plug that in instead. I'm going to cut and then paste it again because we don't have a reset button yet. So now if we do something like it's a little bit computery, but you can sort of see the effect that we are trying to create. So I'm going to give my PFT object a slightly longer, what do they call it as? Just the FFT size. So it's how many samples we're sending into it basically. Should, he says, lengthen the size of the audio sample it makes. So you can see it's not repeating quite as quickly. You have a slightly longer tone, and you get a bit more of the audio sample, and it sounds less robotic. So now that we've got that, the next thing we want to do is be able to actually clear this buffer while we're in there and re-record different samples on top of it. Because at the moment, if we turn that on, I'll need to mute this just to let you hear what actually starts coming out of this. So yeah, the buffer starts basically reloading on top of itself, or the matrix values start getting very confused, so that you just get this sort of machine garbage coming out of it. So I'm going to open back up our PFFT, and the easiest way to actually alter this is we can use general matrix terms. So I might not have known much about the audio, but this is where I come into my own. So we can simply pass the matrix a clear message, and that will eradicate anything that's in it. I'm going to make a second inlet, connect that up. So now, in theory, if we send a bang to inlet 2, it will clear the matrix before recording the new one. Save it. I'm going to cut and paste. You can see we've now got our second inlet. Put that to the output, put that to there. Do a second bang. So now if I turn it on the DSP and record something, I can clear it instantly, so it's not replaying anything back. What I would say is something seems like it's a bit funky at the moment. Yeah, that definitely shouldn't be making that noise. It helps if I connect on the microphone when I'm trying to sing into it as well. There we go. But we would run into a problem, so we want to be able to stack these sounds. But if I create 2 of everything, so that's there, that goes into that, that goes into that. So now it should still work the same. But you can see already, coming out of the other PFFT, that I've not even controlled is the exact same signal. And that's because although they're independent objects, they're both referencing the same matrix at the moment. Now the reason I gave it just an arbitrary name earlier is because we're going to go back in and we're going to set that as well every time that we load the patch. So let's go back in and have a look at what we're doing. So if we edit mode, unlock, and then reference, I always get it wrong, you can see in the matrix controller it expects something called name the matrix, and catch as well. The other the peak down here also looks for something called matrix name. So we tell the matrix to save it into a new place for every PFFT object, and we tell the peaks to go and reference the same matrix that we're saving it into, and in theory we should be able to recall back different samples at different times. So I'm going to make an in3, and then I'm going to prepend name, and then prepend matrix underscore name. Just double check that. That is matrix name, and this one is name. Plug that in there, and this into these 2. That and that, that and that. So now we pass it a single message, what we want to call the matrix, and inside the PFFT it will automatically route and set it up so that each of our objects has a different name, as long as we pass it a different name. There's probably potential where you'd want to have different FFT objects accessing the same matrix, but not in this case. So I'm going to close it and save it. Now, if I delete that one and we need to reload it, so I'm just going to cut and paste it because it's slightly quicker. Give it a sample, give it a bang. So now our reset button is actually 2, and our input is going to be mat1. Oh, that's mat1. I'm going to pull out a second and plug that in there, and so that we should see straight away whether it's replaying the same sound or not. I didn't bang this, so now if I bang it, excuse me, you'll see that it has changed the frequency, but it's not set up quite right yet for some reason. Into does go to clear. That one. There we go. I presume it's just the sort of the DSP, the audio processor inside Mac being really funny for some reason when we changed it on the fly like that. So I'm going to make a second one called Mat2. Give it the same buttons. I'm actually going to do a little fancy trick here where I'm going to plug our reset one into the bottom of our set one, which means that every time that we want to record a new one, it will automatically clear the existing matrix. I'm going to bang that, I'm going to bang that, I'm going to put my voice in here as well. So let's do and so we have one voice and two voices. We'll need to go back and sort out a way to actually mix them slightly better, but you can see where we're going. And that object I was getting really confused about earlier is what we're going to use here. So instead of just simply adding the effects together, which is a perfectly reasonable way of doing it, I guess, we are going to do the matrix tilde. So signal routing for matrix. We want to have 2 inlets and 2 outlets. And this, if you're familiar with it at all, should properly mix the signals for us without any loss. And we want to mix the first and second inlets. So this is where it's going to get confusing because it works in an array. Matrix is an array of signal connectors and mixer adders. It can be any number of inlets and outlets. So we want to turn on 1 and 1 basically. So we want to say this is sort of how it's done. So mix inlet 1 to outlet 1 with a gain of 0.5 and mute inlet 1. So basically, if we wanted to send inlet 1 equally across both our outlets, we would do 1, 1, 0.5, 1, 0, 0.5. So that was 1, 1, 0.5, and then 1, 0, 0.5. So in theory, spectroscope, so that should take the the information from the second inlet and put it on the second outlet at 0.5 mix. We could do that at point 1, and it means that whatever's coming on the right hand side should go out the right hand side at a gain of 1. We want to do that for the second as well. And then we need to send it for the left inlet. So now, both of our signals are mixed evenly across both of the outputs. It's still a bit different because we've got a gain going into it, which we probably shouldn't have. But for now, it's good enough to get where we want to. So we can take our signals, I can turn that down, and I can make a new one. And then still mix back in my other sample because we've got two different matrices holding two different amounts of data. So we're going to make a few more changes and then wrap this up and put it in as the freeze effect inside the main AES patcher. So I'll come back to you in a few minutes once I've made the changes and sort of talk you through what's happening there.